discuss in the today's session what is the meaning of a comparator. So we will discuss about a comparator, the history of that in the lecture. It is that what is the important of protection system in your transmission system, because our protection means there are the various types of protections are used in the transmission line, and also in that the transmission sector, generation sector and distribution sector. There are the various types of protection are we will use in that protection system. There are the various types of relay are we used from that transmission system, and also in the distribution and the generation system. There are the various types of protection, or there are the various types of relay we are used in the past, also in the today's life. In that past, we will use a electromechanical type relay. Basically, the relay has three types. First one is your electromechanical relay. Then second is your static relay, and third one is your microprocessor based relay. There are the three types of relay. In that electromechanical type relay, there are the various 6 types of relay. There are, according to their constructions, they are the types of their relay are arranged. But in that lecture, we will discuss about what is the static relay, and that static relay, the principle is about or your comparator techniques. This static relay means this static relay are operated on the principle of a comparator techniques. So actually comparator means what? In the detail we will discuss in that lecture. Okay, so we will start the comparator. In that comparator, when in that power system, this is your in that power system, when fault occurs, there is a faulty system. At that normal condition, no any fault occurs on a system. At that case, the when fault occur on a system, the magnitude of voltage and current and phase angle between voltage and current may change. These quantities during faulty conditions are different from those under healthy conditions. Healthy condition means at that case, no any fault occur on your system. This is your healthy condition, and faulty condition means your voltage and current are the changes of their magnitude, and also your phase angle between voltage and current. This is your faulty system. Okay, in that system, these quantities during faulty conditions are different from those under healthy conditions. And the static relay circuitry is designed to recognize the changes and to distinguish between healthy and faulty condition. Means your static relay circuitry, it is designed for the purpose of changes between their voltages, current, as compared to your magnitude and your phase angle. Okay, so either magnitude of voltage or current or corresponding derived quantities are compared, or the phase angle between voltage and current, their corresponding derived quantities are measured by a static relay circuitry, and trip signal is sent to the circuit breaker when fault occurs. The relay basic funda for the relay is what about? When any fault occur on a system, the sense their fault and then send signal to the circuit breaker. The what is the means? Your relay means there is a basic function means it is sensing the relay. Okay, so this relay sensing sends signal to the circuit breaker. Each relay there is a main function for that. It is to sense their any faulty condition and send tripping signal to your circuit breaker. In the 3 types of relay, the relay purpose is same. But in that static relay circuitry, there is a comparison in between magnitude of voltage and current and your angle of voltage and current. When the difference between that two quantities, then this static relay circuitry compare this technique, and then trip signal is sent to the circuit breaker when fault occurs on your system. Then the circuit breakers are there, further actions are takes place, and after that actions they close their contacts and your system is on a healthy condition. It is occur after when circuit breaker is after condition of that your circuit breaker. The part of circuitry which compares the two actuating quantities either in amplitude or is a phase is known as your comparator. When you compare amplitude, then this comparator is known as your amplitude comparator. As the name suggested, when compare only amplitude, their comparator name is your amplitude comparator. And when you compare a phase, then this comparator is named as a phase comparator. So their comparator, there are the two types. First one is your amplitude comparator and the second one is your phase comparator. So these two comparators are detailed study in the next slide. So this is your amplitude comparator. So what is the definition for that amplitude comparator? So the as a name suggested by that comparator means an amplitude comparator compares what is the quantity of the two input quantities. Means your two electrical input quantity means your magnitude of two input quantities irrespective of their angle between them. Only magnitude of two quantities it has to be compared. This known as your amplitude comparator. One of the input quantity is an operating quantity and rather other quantity is your restraining quantity. Means there are two quantities, operating quantities and the restraining quantity. When the amplitude of the operating quantity exceeds the amplitude of the restraining quantity, at that case your relay sends a tripping signal. In that electromechanical type relay, you have discussed is that the basic funda of any relay, when your operating quantity is greater than restraining quantity, then this relay, it sends a tripping signal to circuit breaker. In that case, it is the same funda it is operated. What type of funda? It is operating quantity is greater than your restraining quantity. When your amplitude comparator operating quantity is greater than the amplitude of the restraining quantity, at that case, this static relay sends this signal and its signal sends to your circuit breaker. It is your amplitude comparator. The next one, the next type, it is your phase comparator. In that case, a phase comparator compares two input quantities in a phase angle irrespective of their magnitude and their operates. So, in that case, the function for that phase angle is that if the phase angle between them is phi is less than or equal to 90 degree, at that case the phase comparator it is operated. Means the viewer phi is less than or equal to 90 degree. At that case this phase comparator relay are operated, and then operate means your relay sends this signal and sends tripping signal to your circuit breaker. So this is your two types of comparator. Then in that case, their function is that as per the definition from that amplitude comparator and phase comparator, in that amplitude comparator only we have to measure the amplitude irrespective of their phase comparator. And in that phase comparator only measure or compare your phase irrespective of their magnitude. But in other case, this is your duality between amplitude and phase comparator. What is mean by duality between amplitude and phase comparator? In that case, we have to measure both the comparison. Means your amplitude comparator is act as a phase comparator and the phase comparator is act as an amplitude comparator. How it is work? By using your duality between amplitude and phase comparator are discussed in that slide. So this is in that slide. There, the second point is your amplitude comparator used for a phase comparison. So what is the concept? How the amplitude comparator are used for phase comparator? Because the definition says that when amplitude comparator only compare amplitude irrespective of your phase comparison. And in that phase comparator, only compare phase irrespective of the amplitude comparator. But in that case, the duality between amplitude and phase comparator, this is technique, it is used for both amplitude as well as phase comparison. How these techniques are work? Then this block diagram and phasor diagram, then these are done by using the block diagram and phasor diagram. We have to explain here. In that case, amplitude compare used for phase comparisons. Means this is your figure number 2.19a. Here shows amplitude comparator as a phase comparison. So in that here it is a block of amplitude comparator. There are the two input quantities. First one is your M and second is your N, and the output of that amplitude comparator. And in that second figure, it is an amplitude comparator used for. So the same block diagram is that, but there the inputs are changed. In that case, M plus N and M minus N. There is the two inputs and one output. Here, M is your, what about the M is greater than N? Means your M signal is your, what is the formula for that relay? When the relay is operated, it is operating quantity is greater than restraining quantity. So in that amplitude comparator, the M, it is represented a operating quantity, and N, it is represented your restraining quantity. When your operating quantity is greater than restraining quantity, at that case your relay is operated. So there is your terms and conditions here explain that operates when M is greater than N. Means your operating quantity is greater than restraining quantity. At that case you are operate of that relay. So here in that second figure also it is mentioned that operates when the M plus N signal, this is your operating quantity signal, and then M minus N is your restraining quantity signal. This operating quantity signals is greater than restraining quantity. At that case your relay operated, and also some conditions are there, because this condition is satisfied when only when operating quantity is greater than restraining quantity, also phi is less than 90 degree. At that case, your this type of relay have to be operated. So in that next here, in that figure, that the three phasor diagram of an amplitude comparator. So this is the phasor representation of amplitude comparator used for phase comparison. First diagram represent a comparison M plus N. It's less than M minus N, because the in that slide there are the three condition of phi. So in that figure number A, figure number B, and figure number C, here shows that in that figure A, phi is greater than 90 degree. In that figure B, here shows that phi is equal to 90 degree. And in that third figure, or the figure number C, it is a phi is less than 90 degree. When our relay is operated, when the phi is 90 degree, phi is less than 90 degree, at that case only our relay is operated. Okay, so the in that figure A here shows the M plus N signal and M minus N signal, means your operating quantity is less than restraining quantity. Here shows, because your this axis is your M axis and this X axis is your N axis, and the combination from that phasor diagram, this M plus N, because your phi is greater than 90 degree. So in that case, your operating quantity is less than restraining quantity. So, and also the phi is greater than 90 degree. So this type of relay are not operated, because our relay condition, what about operating quantity is greater than restraining quantity and phi is less than 90 degree. So the figure A, these conditions are, in that case the relay is not operated. Then the figure B here shows phi is equal to 90 degree. At that case both the diagrams show same, that is your mirror image. So in that case, m plus n is equal to m minus n, and also the phi is equal to 90. So this is not your relay operating condition situation. So in that case also these relay are not operated. And that figure number C here shows that the m plus n signal, it is greater than m minus n signal, means your operating quantity is greater than m minus n, means your restraining quantity. So, and also the phi is less than 90 degree. This is your relay operating condition when this amplitude comparator act as a phase comparison. So, this is the explanations are done in that here. When phi is less than 90 degree, then m plus n means your operating quantity is greater than m minus n, and this relay operates and the modified input. So the phi is equal to 90 degree and greater than 90 degree, this relay does not operate. Okay, so this is the case when amplitude comparator used for phase comparison. And then second one means your duality means amplitude comparator as a phase comparison, and the second one is your phase comparator used for amplitude comparison. Same block, but the diagram is changes. In that block we have to written in that next previous concept amplitude comparator, but it is the case, it is a phase comparator used for amplitude comparison. So in that block, it is in that figure A, it is your phase comparator, first block diagram. In that case, the first block, it is represented a phase comparator, the two input quantities, M and N, and last is your output. So M is your operating quantity and N is your restraining quantity and the output. And the figure B, it is a phase comparator used for amplitude comparison. So in that case, M plus N is your operating quantity and M minus N is your restraining quantity. And here it is a output. And when this relay are operated, the first figure in that case written is that operates when it is a phase comparator. So it is operated when phi is less than 90 degree. And when phase comparator used for amplitude comparison, when operates when here the symbol, it is represented a lambda. Lambda is a less than 90 degree, and this condition is satisfied when operating quantity is greater than your restraining quantity and lambda is less than 90 degree. In that previous case of amplitude comparator used for phase comparator, the amplitude condition or the relay condition is m plus n is greater than m minus n, but phi is less than 90 degree. In that case, only letter is different, that is your lambda is less than 90 degree. Okay. So it is also we have to discuss from that phasor diagram. So this is your phasor representation of phases comparator used for amplitude comparison. So in that figure A, when this lambda is greater than 90 degree, in that second figure, it is shown that m is equal to n, and in that case, lambda is greater than 90 degree also, and also in the comparison, lambda is less than 90 degree. Okay, so there is a three cases here shows their vector representation according to their comparison when m is greater than n. That this is not a relay operating condition. M is equal to n, at that case their relay is not operated. When the relay is operated, there is your m is greater than n. M means your operating quantity is greater than restraining quantity. At that case, your lambda is less than 90 degree. At that time, this type of relay operated according to their vector diagram representations and then signals of their combination of that signals. This is achieved that this amplitude comparator act as a phase comparison, and that phase comparator act as an amplitude comparator. Means your duality applications are done by using the block diagram and vector representation. Okay, so this is your main thing in that comparator, means your static relay comparison technique. This is the whole the static relay. Then we go to our next type of relay is that differential relay. Okay, so differential relay, as a name suggested, a difference means difference between that two case, means you are a differential relay. Simply it is suitable connected overcurrent relay which operates when the phasor difference of currents at the two ends of protected element exceeds a predetermined value. And most of the differential relay are of current differential type. The following are the various types of differential relay. The differential there are three types of differential relay: simple differential relay, percentage differential relay, and balanced differential relay. Okay. So this is our simple and differential relay. This differential relay are used, we have to use in your transmission line protections. This simple differential relay is an overcurrent relay. And what is the overcurrent? Overcurrent when the relay current exceeds, at that case their predetermined value, when we have to set a value, at that case when this value, after that value, this overcurrent relay operated. Means your simple differential relay is an on the principle of overcurrent relay, having operating coil only which carries the phasor difference of currents at the two ends of a protected element. And it operates when the phasor difference of secondary current of the CTs at the two ends of the protected element exceeds a predetermined value. Okay. The secondary of CTs at two ends of protected element are connected together by a pilot wire circuit. The operating coil of the overcurrent relay is connected to the middle of pilot wire. The differential protection scheme employing simple differential relay is called as a simple differential protection or basic differential protection. The simple differential protection is also called as a circulating current differential protection scheme or merge price protection system. So this is the representation of simple differential protection scheme behavior under normal conditions. This scheme is also, it is a single source. Why? Because only one source here it is connected. It is the your source or generator system. This is your CT1. It is your CT2. This is your protected equipment. And that protected equipment, both sides, here circuit breaker are connected. And this is your transmission line. And in that these CTs are connected by a wire. This wire is known as a pilot wire. Okay. In the pilot wire, there is a relay. It is connected across there. Means in that pilot wire, we have to connect a simple differential relay. This is OC relay, means over current relay. Okay. And this is your primary current. I1 is equal to load current or line current, IL, and I2 is equal to IL. So this is for CT1. From CT1, the current directions are here mentioned from that overcurrent relay. And the overcurrent relay condition is that I1S minus I2S is equal to 0. I1 is S means your first incoming current is, and I2S is your second incoming current. When incoming current is equal to 0, this is your normal operating condition. The relay is not operated under a healthy conditions. This type of relay is also known as a merge price protection system. So this is your simple differential relay at normal operating conditions when fault occurs on system. Means in that case, the line, there are the various types of fault according to your unsymmetrical fault, symmetrical fault. Unsymmetrical means there are the various types of line to line fault, line to ground fault, double line to ground fault. Any fault occur in a transmission line or in your line, this is your external fault. At that case, what type are occurred in that simple differential protection is that there is your CT1, here it is CT2, both the circuit breaker are connected protected equipment. But this is your simple differential protection is when it is operated, when internal fault occurs on your system, at that case, this differential protection system are work. Otherwise, they are not work in normal or healthy condition and external fault are occurs because your CT1 and CT2 current are not changed. Then there is when internal fault occurs on system, means your protected equipment, at that case their internal fault occurs. In that case, your current one, I1S and I2S, in that case there is a difference between the first CT1 current and CT2 current. So there it is not equal to 0. When it is not equal to 0, this is your simple differential protection are operated. And then it is strip signal sent to your circuit breaker and this type of relay are operated. But there are the drawback of that simple differential protection. What about the drawback are there? When your external faults are occur in your system, but this external fault, when we occur that external fault, this line current is exceeded at your normal rated current. Due to that exceeding current, this CT2 senses this current, and this current sensing from CT2, from that CT2 current passing through, it is I2S, is nothing but our external current. So in that external fault condition also, this type of relay it is operated. It is